How's it going, everyone? Welcome. Gabriel Gonzalez, barely here, and you can barely see me here. It's because, well, I have some issue with the lights, so the handyman, I already text him, so I hopefully he come at some point in the next few days. In the meantime, let's going to now continue to look at this particular course from the CSS, shall we? Right, this fundamentals recap about what CSS, the quick recap from the MDN docs, which says that hey, describe what CSS is, also how you can add styles to your CSS, whether it's inline, external, or external uh, uh, Jesus, external or via inline styles. So external files, internal uh, or inline, right? And the differing of each one of them. Uh, Also, how you can now select or look at the most common selectors, all right? Such as for the elements on the class and the uh, selectors, such as the combinators, all right? Using it, for example, the descendant or the next to sibling or the direct children, all right? As well as the state base. And it's important at least to understand this way of how you can select at a high level perspective, of course, uh, elements in the DOM to apply some rules so we can now have a better understanding of when we need to apply certain styles, we know how to do it, what are our resources that allow us to. So this is one, okay? And the other is these special functions, right, or the additional features, such as functions like calc to perform some mathematical operations. So calc, color, transform, uh, and the add rules, which is you are specifying is CSS behaviors, okay, such as hey, with media, I want to specify is what are the set of rules that are going to be applied giving a particular breakpoint. All right, min, max, you name it. Okay, and for example, that layer is you want to define several cascading styles. All right, that you want to apply. They overriding one on top of another. All right, and you also have the transition. The keyframes to indicate is the intermediary animations that needs to happen, or the keyframe. The view transition, which is something that I didn't know what it does. I don't know what actually does. But it's important to understand that that also exists, as well as the include, the import to import an external CSS file. So all of this stuff is just as a way to, and also the another part of the CSS, which is the comment. So I'm doing is because I want to look up the particular reference, and then anytime that somebody actually tell me something or ask me a question, or even myself I have a doubt, I can rely on these fundamentals of what CSS is, how you can add styles, how you can select and look at the most common selectors, whether it is an element or a class or via an attribute or a combinator, which is a is a descendant selector, or a it's just going to now be a little bit more intention about this. The selectors, such as whether it is pseudo classes or pseudo elements. So pseudo classes is state based. Pseudo elements are now particularly elements that you should apply or you can apply to this. all right? As well as the combinators, descendant, or next to sibling, or the first elements. And here is where I want to hit the brake a little bit, right? Because we look now, all right, and also in a particular way of how you can. This is part of the introductions. Of how you can get the most out of this course by understanding is several part of this, whether it's blocking or interleaving. Again, science is trying to, there is a particular paper here, science is trying to find how, what is the effective way to do something, all right, or understand is the true nature of stuff, right? Again, this is for the material world, right? The world where we live in, right? When it comes to now recognize what is effective for you, there I will say that it boils down to the desire. If you truly want to know something, you will figure it out. That's all I can say. There are several stuff that you can do. For example, it's like, well, schedule your learning, schedule all of this kind of stuff. What are the time that you're going to put on this stuff? And one of them is the error correction, or the other is follow instruction. So you follow instruction, which is the most common way of learning of this particular workshop. So you follow the instructions and then you replicate that behavior. And the other is the error correction, which is you now, so you now go out with a gun, and then you're figuring out that if you shot somebody, you're gonna get to jail. So the idea is prevent that kind of mistakes. So how you can do that is by, well, understand that if you do that, there are some consequences, okay? And also is when you're trying to learn something that is new to you, is through the errors, is that how we're going to get feedback to improve our neuroplasticity. So again, this is something that go beyond the scope of this, all right? And I find out that when I do errors, all right, and this is true especially as I do this stuff, as I do this kind of stuff, and yada yada yada, when I do errors, it is an invitation for you to correct that behavior, okay? So I think this is also true, especially for physical stuff, and when you have to hit somebody, stuff like that, then you focus is on that. So, well, you name it, you get it. So in any case, here we are, okay? This is it. As we go and progress, French toast. Okay. As we go on in this particular course, where we first look at the anatomy in this conceptual stuff, which is important to know, is the anatomy of a style rule. What is a style rule? What is a selector? Exactly. So, the other is shorthand's property. This is now the fundamental of this. Okay. So the way of how you can add CSS into your document, how you can select elements, and the most common one, additional features, the add rules, the additional features, and the shorthand properties, followed by the comment, and some couple examples. So the anatomy here is to understand what is a rule, the entire stuff, the selector, what is a declaration, which is a property and a value, and what is the first declaration of a rule, you know, what is a unit, uh, and all this kind of stuff is just to make sense of this anatomy. And then we look at the media queries, all right, as a way to starting to see is again the most common things that we're going to use along the way, as well as the selectors. And in selectors, first that we looked at from the tags, okay, to target specific tag or classes. All right, so here we're targeting a specific tag or classes. All right, and since most of these are generated by our modern CSS tool, it is important yet to understand few of them or nifty selector that come handy even with modern tooling, and that is pseudo classes. For example, like hover, focus, okay, and remember that all of these pseudo classes or state-based selectors is that internally they are now handling that state. All right, quite obvious, quite duh, but it's the essence and the reason why instead of you having to create a particular logic in JavaScript to handle that, you can rely on the behavior of the browser. This is the beautiful stuff of this selector state base, right? So instead of you having to create that functionality, and you can create that, right? There's nothing wrong with it. You can even say, hey, let's go to define now here and immediately invoke function expression that is going to now create a close over, some way to keep track of that state, and therefore return some functions to update that state and yada yada yada. I can quickly create that, and I have the mental model to do that. However, this tracking mechanism sometimes is overkill, and we don't need to do that because we have now this state based rules or state based selectors. So if you're gonna use a particular tag, check what are the state based selectors that you can use this. So for example, the most common one is the hover with anchor tag. All right. The other is focus. Why focus is so important, or why we even care about focus? Because this is helpful for accessibility, something that we barely know. I honestly I don't know what it is. For the accessibility here, okay, and now how accessibility is great for non-pointer devices, right? So any people that at least have some sort of disability or cannot use the mouse properly, it is something that a lot of companies, especially if you're going to provide that to if you're going to provide your service to the government, they are looking for, right, the web content accessibility guidelines here, provided by the triple W consortium, the W3C, and the web content accessibility guidelines. Again, I am not familiar with this. I am not familiar with this. All right. I am not familiar with this. But we are going to get ourselves familiar with that. The primary intent for is web content developers, page authors, site designers. And where should I start? Okay, that's interesting. For introductory research, see accessibility fundamentals overview. And if you want a really short introduction to 3 web accessibility issues, alternative text for image, keyboard input, and transcript, see example of the web accessibility. Oh, this is if you want, okay. Introduction, okay, this is a huge intro to that, right? A huge intro to that. Accessibility is about people. but as long as they're productive. And then some example here. Alternative text for image. Equivalent alternative, so alternative, key inputs, for example, some assistant technologies, all functionality available from a keyword. Then people with disability can use assisted technologies that mimic the keyword, such as speech input, transcript for audio, just as image aren't available to people who can see, audio files aren't available to people who can hear, and providing. Interesting. I think this is what the most common example. Exactly. Is provide for image and text information. The other is the keyword inputs. Some people cannot use a mouse, including many older users with limited fine motor control. An accessible website does not rely on the mouse. It makes all functionality available from keyword. Then people with disability can use assisted technology that mimic the keywords, such as speech input. The other is assisted technologies. All functionality for that. Keyword. No keyword trap. Make all functionality available from keyword. Interesting. A drawing program. A drag and drop features. Moving between connection discrete. A section. Painting programs. A section. Model helicopter flight training simulator. Okay. Okay. Model helicopter flight training simulator. A model helicopter flight training simulator has an exception because the nature of the simulation is to teach real-time behavior of a model helicopter. Examples is a PDA with optional keyword, and so on and so forth. Right? Makes sense. W3C Web Accessibility Initiative. No keyword trap. Okay, so this is the reason why we are looking is the why. WAI, Web Accessibility Initiative. Web Accessibility Initiative. And the goal of Web Accessibility Initiative Web Content Accessibility is to provide a single shared standard for the web. The four guiding principles of accessibility is poor. You shouldn't. That's a bad acronym, bro. Poor. P-O-U-R. P-O-U-R. Poor. No, you can do this. Anyway, those four principles are perceivable, operable, understandable, and robust. So this is the four guiding principle of accessibility, okay? Which is perceivable, whatever sense you want to use, image, mouse, or haptic, is perceivable, operable, understandable, and robust. So again, this is the principle of, or the four guiding principle of accessibility. Why are we even care about this? You know, the word accessibility. And the four principles of, WCAG, which is Web Content Accessible Guidelines, accessibility guidelines, accessibility guidelines. What in the F? Okay, accessibility guidelines. All right. which is pour. You can't do this. And pour stand for perceivable is perceivable, operable, perceivable, it is useful or operatable, operable, is that operable is understandable and is robust. Is this web content accessibility guidelines? So okay, that's what we focus our attention on, the focus, right? A part of these pseudo classes, and the other is a check. Again, something that we are going to see a lot of the time. Also, the first and last child. If you want to pick now that particularly first element, all right, you can use the first last child. However, you can also use it the first die off, since now this is going to correctly check is the first, exactly, is going to check the first type of element here, because if you say the first child, it means that is the first element that is exactly, if the first element there is a from the parent, okay, and that match this selector, all right, you're gonna do that. If you use now the type, you say, hey, whatever element appear on whatever pattern element appear here, the first of this type, I want you to apply this. As a subtle difference here, you know, and why this actually works like the first child. First child is looking is for the first elements, the first child element with that are inside the parent. Okay, the name is pretty descriptive. First child, and the other is the first of type. So this pseudo classes, these nifty pseudo classes, are tremendously helpful, especially if you're going to dive deep into the CSS, even with modern technologies. The other is the pseudo elements, which is allow you to, for example, is adding adding elements here, and therefore, yeah, adding elements that most of the time it is useful for, it is a decoration before and after, and the other is a placeholder, right? So even though that placeholder are explicitly are for creating that, especially if you're gonna use now a how do you put it? If you're gonna use a form to identify that has all the information that you need in that form, use labels, not the placeholder. The placeholder is to indicate is what is the value that this is an example of these values. And then we look at the combinators, you know, the child selectors, the descendant selector, the child selectors, and pretty much that's it, right? Well, it's not that hard, a particular exercise, how you can check that, right? We did this, so no problem. And then we jump to the color. All right. Then we jumped here to the color here. So color in CSS is a huge topic. Here we go. There you go. And now colors. Color, right? Color. So color in CSS is a huge topic, and one that we'll revisit it through this course. We'll learn how to do a lot of the phenomenal things with color, but for now we'll focus on the basics. we can adjust the text color of an specified element using the color property. Yeah, we can adjust the text color of a specified element using color property. Okay, and then you have now color formats. Okay, we'll learn how to do a lot of the phenomenal things with color. Okay, exactly. So we are going to see throughout this throughout this course about color. All right. Which is great. About color. About color. But for now, we're gonna focus on the basics. For now, let's see the basics, please. Which is the color format. Yeah, color format. All right. So these color formats include many different ways to represent color. A lot of the developers use X, but I believe there are better options. Okay. Yes. So a lot of developers use X, right? So for example, like this. HexCode, hexadecimal codes. So it has this, right? But there are better alternatives. Okay, so far so good. Let's see what those options are. Prefer a text format? The video below explores how 4 different color format works. If you prefer to read an interactive article on the same subject, check out my blog post, Color Formatting CSS. Here you go. Okay.
So in CSS, we have quite a few different ways to represent color. And here I've selected 4 of the most common. We have keywords, which are things like red and ocean blue, hex codes, RGB, and HSL. And I want to talk through how these different color formats work, what the pros and cons are, and which one you should actually be using in your applications. And let's start with keywords, because I think that they have one very, very practical purpose, which is we have a keyword. So in CSS, we have quite a few different ways to represent color. And here I've selected 4 of the most common. We have keywords, which are things like red and ocean blue, hex codes, RGB, and HSL. And I want to talk through how these different color formats work, what the pros and cons are, and which one you should actually be using in your applications. And let's start with keywords, because I think that they have one very, very practical purpose, which is for educational content like tutorials and this course, right? You see the word red, you don't have to do any mental calculation. You know roughly what you're going to get. So it's very decipherable. But the trouble is that in a real application where you actually want to have a color theme, you're going to need multiple shades of the same color, and there's not really any way to tweak that. And the ambiguity of like, well, what color is it exactly? That's also a bit of a problem. So it's useful in educational contexts where you just need like a placeholder color, but we're not really going to use those in our real applications. Next up, I want to talk about hex codes. And this is probably the most commonly used color format. I think people like them because of how short it is, right? It's easy to write, it doesn't take up a lot of space, but that terseness comes with some pretty big disadvantages. And the first one is that it's inscrutable. Like, what does this actually mean? And if you're familiar with the hexadecimal numbering system, you can make sense of it, but it's still not as easy as I would like. I do think it's worth talking through how this color format works just because it is so common. So the way hex codes work is we have 3 different values that take up 2 digits each. So these first 2 Fs represent the first value, And this is the value for red. The next two numbers are the value for green. The last two numbers are the value for blue. The reason you see the letter F instead of a number is that it uses hexadecimal numbers. So unlike decimal numbers that go from 0 to 9, hexadecimal numbers go from 0 to F, so 0 through 9, and then A through F. And this means that instead of 10 possible values, there are 16 possible values for every digit. If we do the math, 16 times 16 means that we have 256 possible values for these two spaces, which, I mean, you can kind of see from this little bit here, and you may already be familiar, is how many colors we actually have in RGB color. So hex codes are a way to represent RGB color. We have the number for red, number for green, number for blue. If you mix those values at different ratios, you can come up with just about every color. Now that I've explained that, you can probably look at this and say, okay, so it's all red, right? Like a lot of red, and then no green, and then no blue. So this is a solid red color. But you know, in a real application, the hex codes look more like this. And figuring out what color this actually is possible, but it does require a bit of a mental workout to get us there. The RGB color format, it's really kind of the same color format, right? Like it's the exact same information, just represented in a decimal system instead of a hexadecimal system. But it does come with a pretty big advantage, which is that now we can easily tell what these numbers are in a numbering system that is more familiar to us. So I don't have to do the conversion of like, what are the actual values for the red, green, and blue channels? So that's an advantage. The disadvantage, and both of these share this disadvantage, is that it's not actually clear when looking at a color, how do I transform this into another color? Like let's say, for example, I wanted to make this color a bit less saturated, a bit less vibrant. I wanted to gray it out a little bit. How would I do that? It's not actually super intuitive.
So we don't have the mental workout of HexCode, but for nuance colors, all right, for nuances color, how can we do that? All right.
And that takes us to the HSL color format, which is by far my favorite and the one I recommend that you use. To help me explain how this works, we're going to use a color picker. And it's a color picker I created kind of for this context because most color pickers don't actually use HSL. It's kind of annoying. They use HSB instead, which is similar, but slightly different. We have three values. The first value is the actual hue, and it's represented in degrees. And if you're not familiar with this idea of hue as degrees, it might seem a little bit strange, but I think it helps to picture it on a circle, right? The reason that we use degrees is because the value is circular as you come around the circle, right? 359 degrees, you go up by another degree, and you're at 0 degrees. It wraps around. So that's why we choose this value. And the hue is the actual pigment in the color, right? What color is being used? Is it purple or yellow or red? But that one value doesn't tell us anything about what the actual color should be. We need two more pieces of information. The next value is the saturation, and this, as I was talking about earlier, is how grayed out or vibrant the color is. So in this wheel, we're seeing all these colors at full vibrancy, but if I drag this handle down towards the left, we see that it is slowly becoming grayed out, monochromatic. And if I drag it all the way to the end, something kind of interesting happens, which is that the hue doesn't matter anymore, right? Because if there is 0 pigmentation, it doesn't actually matter what the pigmentation is. Finally, the lightness value. So on the other axis, the up-down axis, we can get our color to either be lighter or darker. When we're right in the middle of the scale, we're kind of not making it brighter and we're not making it darker. So right in the middle is the like purest representation of this color. And as we go up and up and up, we eventually hit a point where we are pure white. And similarly to when we had 0 saturation, the hue doesn't matter because there's no such thing as a pink white or a blue white. There are off-white colors if we go down just a little bit, but if I'm all the way at the top, it's just pure white. And similarly, the saturation doesn't matter because white, by definition, doesn't have any pigment either. The reason I like this color format so much, and I'm just going to pick kind of a random color, and let's pretend that we're working in our editor, and we don't actually have this color picker in front of us. So I have this color in my application, and I want to use a box shadow, but I want the shadow to be slightly darker and slightly less saturated, right? I want it to be a little bit more grayed out and a little bit darker because that's what shadows actually look like. Incidentally, we're going to talk about coloring shadows in Module 9, which is a long way away from this video, but just do be aware that this is something we'll be talking about. So I can paste in this HSL color, and without having to go to Photoshop and pick a new color, I can tweak the values, right? I can say, okay, the saturation should be lower, and the lightness should also be lower. And I mean, VS Code is kindly giving me a little preview. We can kind of tweak our way to the right color without having to open a color picker. I think this speaks to the intuitiveness of this color format, and that's the real advantage, right? We can read this number and have a pretty good sense what the color is without having to go through all the trouble of opening a color picker. There is one thing that is slightly unintuitive about HSL that I do want to talk about though. So if I put the color so that it is fully saturated and at the midpoint lightness, and I bring the hue down to this blue color, we see that we have kind of a darkish blue. And if I hop across the hue wheel to yellow, I think most of us would agree this is a much brighter color than this one, but they both have the same lightness value. So what's going on here? Why is it that 50% lightness doesn't actually create uniform brightness across all these colors? Well, the way HSL color works is that it is mathematically pure and it doesn't take into account human sensibilities. So in terms of the actual physics, right, how much energy is in the wavelength or whatever, clearly I don't know physics, we have equal values of energy in that light. So it's not actually brighter. Like this color isn't actually brighter than this color. The problem is that humans don't see color linearly, right? Our perception of color changes depending on the light's frequency, the hue. So this is one of those funny things where in terms of the math, it all works out, but it's not quite balanced for humans. And there are new color formats coming to CSS, like Lab and LCH, that do address this, that do kind of create a uniform system for humans, but those color formats aren't widely supported yet. So until then, we'll do our work with HSL.
Oh, I get it. Created by Anthony Lehman, MIT license. Ivory. Fuchsia. Fabric. Orange. Color. Golden. Yellow. Olive. Gold. Goldenrod, dark olive, yellow, dark green, green, lime forest, medium sage, spring, light scene, deep sky blue, dodger blue, midnight blue, dark blue, blue. It is a hodgepodge. So here's something a bit curious. Check out these two name color, gray and dark gray. Dark gray is actually lighter color than gray. Well, this is because the 140 name web color are sourced from different places, including the HTML4 and the heartbreaking memorial. It is a hodgepodge on different palettes, so it isn't always super consistent. You have the RGB, all right, which we are quite familiar with that. The point of this RGB, you can use even RGBA, okay, that actually to use the newer format. Fortunately, browser support is excellent, all right. So for RGB with alpha, it's kind of widely supported, I will say. That's good. But what's the deal with the slash here? It's meant to be a delimiter. It indicates that the first three values are part of a group and last value is something different, and it has nothing to do with division. That you have the HexCode, a good representation of this. Yep, absolutely. Quite interesting. I think you have to create now a tracking for that to represent that. This is part of the results. We specify 80 as an alpha channel, exactly, for hexadecimal, which is equivalent to say 120 128 decimal system. As a result, this box is 50% opaque. 8-digit HexCode are widely implemented in modern browsers, with 96% of HL. Sadly, they are supporting in Internet Explorer. If you have to still working on Internet Explorer, I wish you the best. So far, both of the color format we have seen are different wrappers or representations here on the same fundamental idea, passing a specific value for red, green, blue channels. This isn't the only way to think about color, though. Let's look at the totally different color format HSL. Let's start with the color picker, this time this. Alright, so here we are playing with this. So the color representations in SHL is that the color will represent as, and I really love this analogy that you're using, the color we will represent now is, and the interactivity of this is something that I pay for. Alright, so the color will be now something like this. Alright, and then move that around this. This is also interesting on how you can actually represent this. Okay, so you're going to fill that out. All right, you're going to fill that out. Because how do you can actually create this kind of stuff is quite interesting. So you are creating is like 2 layers here. When you are going to show now is the color painting in this way, right? So if you can think of this as a line to going to from this color to them, and then you somehow try to bend that, because that's what we want us to do here. It's like to bend that in wheel thickness. All right. It's a position and color and the height. I'm going to display this into flexible. Oh, so you already have this. Oh, holy fuck. This fella create this background. This fella create this as a background. Holy moly, mother. French does this. This fella create this background like this. Conic gradient. Oh my god. And the box shadow. And the box shadow. Holy moly, scroll to. Holy moly. So he create now is a background in which, so for example, you have now, I think it's this. We can say, I don't want to show you this. I don't want to show you this. I just want to only show this. Right? Which means is that make this none. And exactly, this is how it create this. But again, you can create this is with the background conic. A conic background, and you have to explicitly tell all of this in a proportional way. Holy fuck. And then you put now something on top of that, like a grid. And then you put something on top of that. Alright. And you say this one to display as a flex. And I want to align the center. That's right. Which is this. Where the background will be now here. And you are now apply not only exactly a border radius, because everything here on CSS is now a so everything here yeah, everything here is a flex box. All right, everything in CSS is a box. So what you do is this. So these are two boxes here. One of them is showing the conic background, showing the color in this conic way. Holy moly. All right. And the other is this. This is quite straightforward because you say, hey, I want to show is this with the background. You know, you can say, hey, this will be the background that I want to show for this. You know, this will be the background that I want to show of this. But is this, you're gonna show is this using background, linear gradient. This is a very good way of how you can actually is understand and apply this. So you're putting here two boxes, and these two boxes are going to be now rounded, both of them. And then, since everything here is a box, you're going to apply this style here in the background, here, in a conic way, all right? And then the same here, and then the same here, but now with a linear gradient, which is gonna show you only where this only be rendered is when you modify is the particular color. And you're gonna do that in real time. Satellite grid model. And the color picker. Satellite grid model CSS. And then you have this. This is one of the reasons why I'm actually diving into this stuff, because I honestly ignore heavily CSS, and the only thing that I can work with CSS is with layout. And there is more than that, bro. And there is more than that. Okay. So the usefulness of this is, since you already have the mental model of color, when you say the first value represent is now the pigment, all right, the color, okay, in a circle. The second value represent is the lightness, is the saturation, exactly, the saturation. Represent is the saturation, the second value. So the second value representing is the saturation or the gray out. The gray out. You have HSL. Okay. That's interesting. So this is useful because this is useful for getting quickly subtle colors for your shadows. Okay, a particular use case. And the mental model of this is much more meaningful. Okay, is much more meaningful. The first value, so the first value is the color pigment. The second value is the saturation. In other words, exactly the saturation, or so the first value is a color pigment. The second value is the saturation. Okay. Like the first value is a color pigment. The second value is the saturation. Or the greatness, or the great. I prefer to use is the word that he described here.
Shadow, but I want the shadow to be slightly darker and slightly less saturated, right? I want it to be a little bit, if we go down just, and if I drag it all the way to the end, something kind of interesting happens, which is that the hue doesn't matter anymore, right? Because if there is zero pigmentation, it doesn't actually matter what the pigment, the saturation. And this, as I was talking about earlier, is how grayed out or vibrant the color is.
How gray out or vibrant the color is. Gray out. How gray out or vibrant the color is. And the third one is the lightness.
Is. So in this wheel, we're seeing all these colors is slowly doesn't matter anymore. Pigmentation doesn't actually matter what the up-down axis, we can get our color to either be lighter or darker. When we're right in the middle of the scale, we're kind of not making it brighter and we're not making it darker. So right in the middle is the like purest representation of this color. And as we go up and up and up, we eventually hit a point where we are pure white. And similarly to when we had zero saturation, the hue doesn't matter because there's no such thing as a pink white or a blue white. There are off-white colors if we go down just a little bit, but if I'm all the way at the top, it's just pure white. And similarly, the saturation doesn't matter because white, by definition, doesn't have any pigment either. The reason I like this color format so much, and I'm just going to pick kind of a random color, and let's pretend that we're working in our editor, and we don't actually have this color picker in front of us. So I have this color in my application, and I want to use a box shadow, but I want the shadow to be slightly darker and slightly less saturated, right? I want it to be a little bit more grayed out and a little bit darker because that's what shadows actually look like. Incidentally, we're going to talk about coloring shadows in Module 9, which is a long way away from this video, but just do be aware that this is something we'll be talking about. So I can paste in this HSL color, and without having to go to Photoshop and pick a new color, I can tweak the values, right? I can say, okay, the saturation should be lower, and the lightness should also be lower. And I mean, VS Code is kindly giving me a little preview. We can kind of tweak our way to the right color without having to open a color picker. I think this speaks to the intuitiveness of this color format, and that's the real advantage, right? We can read this number and have a pretty good sense what the color is without having to go through all the trouble of opening a color picker. Okay. There is one thing that is slightly unintuitive about HSL that I do want to talk about, though. Our new color formats do kind of create a uniform system for humans, but those color formats aren't widely supported yet, so until then, we'll do our work with HSL.
The other concept is transparency. Okay. Certain color formats allow us to supply an additional value for alpha channel. This is a measure of opacity. A default is 1, and you can apply that too. Okay. What's the deal with this slash? what's the deal with the slash? This is to handle the alpha channel or the transparency. Okay. We should be able to see this kind of stuff. So the character is becoming a more common pattern in modern CSS. This isn't about division, it is about separation. The slash allows to create group of value. The first is about the color, the second group is about the opacity. Interesting. Later we'll see how the same syntax can be used with border radius to separate horizontal and vertical radius. It is also used in CSS Grid when an element spans multiple rows. Browser support. The version HCL color is part of the 2016 revision and how color works in CSS. It enjoys wide support but will not work in Internet Explorer. If your project supports Internet Explorer, you will need to slightly different syntax, like this. Instead of being space separated, the values inside of HSL functions are comma separated. If you like the color be transparent, you will need to use HSL function instead of HSL function. This is a legacy format, but is still supported by all browsers. If Internet Explorer support is important for your project, it is better to stick exclusively with this format. Oh, but this is for legacy. This is for legacy. So now the slash is becoming more apparent in modern CSS. That is not exactly the slash character. What's the deal with slash? What's the deal with slash? The slash character is becoming a common pattern in CSS. It isn't about division, it is about separation. That say, hey, this is the group of values. This is to separate is that. The slash allows to create group of values. The first group is about the color. The second is about the opacity. Interesting. The opacity. The first is about the color and the second is about the opacity here. Okay, and then you have now background colors. And then you have now background colors. All right. Only affects color of text. If you want to set the color of the element background, you use is this. So pretty straightforward, something that I'm quite familiar with. All right. And then we have now units. The most popular unit for anything size related is the pixel. Box, width, margin top, and padding, right? You got it in this particular order. So pixels are nice because they corresponds more or less with what you see on the screen. It is a unit that many developers get comfortable with. The pixels. Exactly. And you have M. It's an interesting fellow. It is relative unit equal to the font size of the current element. Of the font size of the current element. If a heading has a font size of 24, we give it a bottom padding of 2em, we can expect the elements to have 40em the cushion underneath, which is relative to the font size of them. Okay, here's a quick playground and try tinkering with the font size. So if you say, for example, font size, and then I say to border, oh, exactly. So the padding bottom here now is 2 times the font size, 3 times the font size, 4 times the font size, now 1 font, you know, or you can say 1.5 font size. You can say 0 for that, so no padding at all, no padding bottom here. But now give it this. And here's another example. Try changing the font size to see how that affects the child span. So, because each one of them has different font size, and we are now applying this to all. Okay. So the font size will be now relevant to the the font size will be relative to the parent in this case. Okay, it will be relevant to it will be relevant to whether it is current font size or the pattern. So you say 32, say 48, say 60. This sentence get quieter and quieter. 48. How often should you use F? I don't often reach of them. I can be very surprising when a tweak to a font size affects the spacing of the sending element. This is especially true when it comes to modern component architecture. Using M's means that a component's UI will change depending on the font size of the container. If you're going to change based on the font size of the container, it is placed within. This can be useful, but more often that's not. It's a nuisance. The rank unit is much more useful in more circumstances because it's not taking is the container font size. It's taking now the root element here, which is always always relative to the root element here. All rams across root elements font size, exactly, which is relative to the container font size, and the other is the relative to the root element font size. So far so good, right? So what a sample the list is. Check out the following playground and then change the HTML element font size. So if I say, okay, the HTML font size here, and somehow I say, now the rank unit is quite a lot like the M unit with one crucial difference. It always relative to the root element. And also, most tags use that, you know? Look at how by default most tags are using that. Notice how all the text scale accordingly when you change the root font size. That's why people like the rank unit, no matter when an element is in the down tree. The rank is consistent. It behaves consistently and predictable, like pixels, but in respect user preference when it comes to increasing or decreasing, and it isn't okay based on user preference. This is the key point. Please note that you shouldn't actually set the px font size of the HTML tag. This will override the user chosen default font size. The only reason we're doing here is to demonstrate how RAM unit works. You shouldn't actually set the px font size on the HTML tag. This will override user choice default font size. The only reason we're doing here is for demonstrative and simulating a user change. If you really want to change the baseline font size for rem units, you can do that using percentage, which is 20 bigger rem value app Y. You're saying, hey, I want you to change now 0% bigger rem values app Y. And the percentage. The percentage unit is often used with width and height and as a way to consume a portion of the available space. As a way to consume a portion of the available space. In this example, we have created a box with a fixed size of this and added a child with a relative child to this. So what to consume is the available space here. So when the size of the box element changes, the child will scale accordingly. Exactly. So of course, so when the box change, the child will modify them accordingly. So take only is, or consume, or render is, it takes only the 50% constant. Okay. And at the height of the 75. When should I use unit? Which unit? I recently published a blog post, The Surprising Truth About Pixel and Accessibility. This blog post aims to answer the pixels versus rem thing once and for all. In the future, I plan on integrating this blog post into this course. For now, I strongly recommend that you check out the blog post. Consider it as a bonus lesson from this course. Okay. The surprising truth about pixels and accessibility. Hardware versus software pixels. Apple Watch and iPhone. So the pixel unit is a bit of a lie. It doesn't actually map neatly onto hardware pixels. If you look at the modern display under a microscope, you realize that they aren't made of crisp little RGB rectangles anymore. Here's a close-up shot of the screen of the Apple Watch and the Apple iPhone. What the Apple Watch Retina display look like?
So as the summer approaches, things kind of seem to be perfect circular Vision OS look, which is going to be very cool to see. Some of the things that we saw is that in Control Center and in the settings menus, and whenever you have these kind of on-off toggles that we've been very familiar with, they're going to be a lot more pill-shaped. So they're going to be more elongated, and instead of being a circular switch, it's going to be more of a rectangular or rounded off rectangle switch that's going to be a little bit more elongated, like I mentioned earlier. Again, mostly UI elements, nothing's going to change functionally. It'll just look a little bit different and make you feel like you have a different. Another thing Apple's going to be doing from a UI element perspective, but also a little bit of a functionality perspective, is if you guys remember back in the iPhone 6 and I believe the iPhone 7 days, remember 3D Touch, one of the best things to ever happen to Apple and iOS that for some reason Apple removed, but they are kind of bringing that idea back a little bit. Right now, if you long press on certain applications, it'll actually pop up a nice little routine of what this tab view can look like and being able to cut on the top, which again is going to adopt this kind of panel-like cutout, and it's going to be a floating design. So it'll still be persistent, but it won't be attached to any bezels or any corners or anything like that. It'll actually be a floating design that sits on top of whatever you're viewing, similar to where the dynamic island is, but we're now going to have a tab view for a lot of first-party and eventually third-party applications. And if you remember with iOS 17, a few years that it felt like you kind of just have the same thing over and over again. So let's motivate us to make more videos like this one. But now we do and UI elements from Vision versus being a more 2D that were highlighted in the FP specifically. So of course, like I keep mentioning, we're going to get some sort of Vision OS inspired UI look and transparent and have kind of this the idea of the home screen. Is that circular look. kind of squircle design that we have with just a much
Really? Okay, has taken close up image. Oh, that's interesting. Oh, now it's no longer. That's interesting. An iPhone. Okay. iPhone XS. Diamond subpixels. Interesting. Holy moly. Okay, so here, so the pixel unit is a bit of a lie. It doesn't actually map neatly onto hardware pixel. If you look at the model display under a microscope, you will realize that they aren't made up of crisp little RGB rectangles anymore. Here's a close-up shot of the screen of the Apple Watch and Apple iPhone. It's not about that. They don't have these rectangles. Now it has this blue, red, and green. Or in the iPhone, it has now is this particular illusion of the red followed by a green and some sort of diamond here or some sort of boxes here. Even before manufacturers start getting creative with pixel grids, there was still a distinction between the physical pixel in a screen and the software pixel we write in CSS. Every time a user changes their screen resolution or zooms in, they change how software pixels map onto hardware pixels. That say, no one of this should really affect how we feel about the pixel unit. It is still the most concrete unit we have. Even though that they don't match that, every time a user changes their screen resolution or zoom in, they changing how software pixels map onto hardware. How software pixel map into hardware. Holy moly, bro. Okay. When should I use which unit? Okay. Holy moly. Alright. Alright. Okay. I don't think this is something that you can skip over, and especially the fundamentals, but that'll be all for this video. Take care. Bye bye. Holy